The next space age probably will not announce itself with one perfect photograph. It will not arrive as one flag, one footprint, one heroic countdown, one billionaire smiling in front of a rocket and pretending physics has been conquered. It is already arriving in a more annoying way, as paperwork, as test flights, as samples under microscopes, as landers in vacuum chambers, as crews training for missions that look less like movie posters and more like plumbing diagrams. That sounds less romantic, but it is also a lot more real. In the same window of time, researchers reported a strange new garnet-bearing rock type tied to Mars. NASA completed Artemis II, then reshaped Artemis III into a practical orbital test for the landers that are supposed to make the moon reachable again. SpaceX pushed Starship into its next generation, while also proving how many unsolved problems still sit between a giant rocket and a working transportation system. Blue Origin moved Blue Moon hardware through NASA testing, while New Glenn reminded everyone that heavy lift is not a spreadsheet. And a comet from outside the solar system, 3I Atlas, gave Webb and other spacecraft a brief chance to read chemistry from another star system. None of these stories by itself is the whole future. Together, they look like a pattern. A space age does not begin when the flag touches dust. It begins when the boring systems start multiplying. So the question is not, did the next space age start? The question is whether we are paying attention to the right signals.
Chapter 1. Mars keeps its receipts.
Start small. Not with a rocket. Not with a colony. Not with somebody making a dramatic speech about destiny while standing next to stainless steel. Start with a fragment of Martian meteorite called Northwest Africa 8171. In June 2026, a team including University of Portsmouth researchers reported something unusual inside it, a garnet-bearing clast, a tiny rock fragment with a mineral that had not previously been identified in a Martian sample. On Earth, garnet is not just jewelry, it is a geological clue. Garnet often forms when rocks are changed by heat, pressure, chemically active fluids, or some combination of those forces. It is the kind of mineral that makes geologists lean forward because it hints at the conditions a rock survived. And Mars is supposed to be simple. That is one of the quiet traps in how people talk about the red planet. Dead planet, desert planet, cold planet, old planet. Put enough adjectives on it and it starts sounding solved. Then a tiny sample says, not so fast. The Portsmouth story matters because it points to geological complexity. The possible ingredients are intense heat, pressure, impacts, magma moving through crust, maybe fluid-assisted alteration. None of that automatically means Mars had Earth-style plate tectonics. It definitely does not mean we found life. This is not that video. The careful version is more interesting anyway. The researchers are not claiming the whole mystery is solved. They specifically caution that the garnet-bearing rock may have formed on Mars, or it may have come from another body and been incorporated into Martian material by an impact. To resolve that, scientists would want isotope measurements, especially oxygen isotopes from the garnet-bearing rock itself. The catch is that the sample is rare, and destructive testing would consume part of it. That is the very unglamorous part of planetary science. Sometimes, the universe gives you a clue smaller than a poppy seed, and the best next test is also the test that damages the clue. But that is exactly why this belongs in a story about the next space age. The future of space is not only about going somewhere. It is about having enough instruments, enough return samples, enough meteorites, enough rover context, and enough patience to understand what those places actually are. Mars is not a brand. Mars is a crime scene with 4.5 billion years of missing pages. Every new mineral is another page recovered from the fire.
Chapter 2. The Moon Program Gets Practical.
Now, zoom out from a grain of rock to a program the size of a government. NASA's Artemis II mission launched on April 1st, 2026, and splashed down on April 10th. It was the first crewed Artemis flight, a lunar flyby, and a test of Orion, SLS, crew procedures, communications, and human operations beyond low Earth orbit. That is a big deal. But the more interesting part is what came next. In June 2026, NASA announced the Artemis III crew and clarified the mission's role. Artemis III is not currently framed as the first Artemis moon landing. It is a 2027 crewed demonstration mission in low Earth orbit, designed to test rendezvous and docking between Orion and one or both commercial human landing system test vehicles from SpaceX and Blue Origin. That may sound like a downgrade if you were waiting for a lunar boot print. It is not. It is NASA admitting the actual problem. Getting astronauts to the moon in the 2020s is not just build a rocket. NASA already has a rocket. It is not just build a capsule. NASA already flew the capsule with crew around the moon. The hard part now is making multiple spacecraft built by different organizations meet, dock, transfer crew, operate safely, and eventually support a landing architecture. That is not one mission. That is choreography. Artemis has become less like Apollo and more like an operating system. Orion, SLS, commercial landers, launch providers, suits, ground systems, communications, mission planning, safety certification, propellant management, lunar surface payloads. Every piece has to work, but more importantly, every piece has to work with every other piece. This is where hype starts getting expensive. If a company says its lander will be ready, NASA still has to test the interfaces. If a rocket flies, NASA still has to know what happens when the spacecraft docks. If a timeline looks beautiful in a slide deck, the hardware still gets a vote. Artemis IV is currently NASA's target for the first Artemis crewed lunar landing, early in 2028. That date could hold, or it could move. Space programs are allergic to clean calendars, but the signal is real. Artemis II moved humans around the moon again. Artemis III is becoming the integration test. Artemis IV is the landing objective. That is what a space age looks like when it stops being a slogan and starts becoming architecture.
Chapter 3. The rocket becomes the bottleneck.
Of course, architecture has bottlenecks, and right now, one of the biggest bottlenecks in the entire space conversation is SpaceX's Starship. Starship is easy to overhype because it looks overhyped even when you describe it calmly. A fully reusable, super heavy lift vehicle, a giant upper stage meant to become a spacecraft, a system meant to launch Starlink, carry cargo, support lunar missions, maybe someday carry people toward Mars. It is the kind of machine that makes normal adjectives give up. But the reality filter is simple. Starship matters because of what it could make routine, not because it is large. Big rockets are impressive. Routine big rockets are civilization-changing. SpaceX's May 2026 Starship Flight 12 was tied to the debut of the next-generation V3 vehicle. That matters because V3 is not just a shinier shell. It is part of the path toward more capability, more reuse, more payload, and eventually, the orbital operations that deep space missions require. The word eventually is doing a lot of work there. For Starship to become the transportation backbone people imagine, it still needs to prove a chain of hard things. Reaching orbit reliably, surviving and reusing hardware, increasing launch cadence, managing regulation and range constraints, and, most importantly for lunar missions, transferring propellant in space. That last one is not a side quest, it is the plot. Any lunar Starship concept depends on sending tanker vehicles to refill a lander version in orbit. That means Starship is not one launch replacing Apollo. It is a system of launches, rendezvous, propellant handling, boil-off management, docking, timing, and operations. SpaceX knows this. In its own 2026 prospectus, the company lists delays or failures in Starship's scale, cadence, reusability, and capability as material risks to its broader strategy. That is corporate language, but translated into human, it means this rocket is the hinge. If it works, it unlocks a lot. If it slips, a lot slips with it. That is why Starship is both thrilling and dangerous to build an entire narrative around. It is not fake. It is not magic either. The next space age does not need a perfect rocket. It needs a rocket that can become boring. And boring, in aerospace, is the most expensive superpower in the world.
Chapter 4. Redundancy Has a Logo.
This is where Blue Origin becomes more interesting than the meme version of Blue Origin. For years, the public story was too simple. SpaceX fast, Blue Origin slow, internet laughs, roll credits. But space infrastructure does not care about memes, it cares about options. NASA selected both SpaceX and Blue Origin for human landing system development because relying on one path is fragile. If the moon program depends on commercial landers, then redundancy is not a luxury, it is schedule insurance. Blue Origin's Blue Moon Mark I, also called Endurance, is an uncrewed cargo lander. In May 2026, NASA said it completed environmental testing inside Thermal Vacuum Chamber A at Johnson Space Center. That testing matters because the moon does not grade on vibes. Hardware has to survive vacuum, temperature extremes, cryogenic systems, autonomous guidance, precision landing, communications, and plume interaction with the lunar surface. Blue Origin describes Mark I as a single-launch cargo lander able to deliver up to 3 metric tons to the lunar surface. Its Pathfinder mission is meant to prove systems that feed forward into later Blue Moon vehicles, including the crewed lander path. That is the optimistic signal. The caution signal is New Glenn. New Glenn is Blue Origin's large reusable orbital rocket, and it has moved from concept into real flight history. Blue Origin's NG-3 mission lifted off on April 19, 2026. But reports around New Glenn anomalies and schedule pressure show the obvious problem. If your lander is built around your heavy rocket, then rocket delays become lander delays. NASA is not blind to this. Reporting in June 2026 indicated NASA was interested in alternative launcher options for Blue Moon hardware if needed, because the landing timeline does not have infinite slack. That is not a scandal. That is what responsible architecture looks like when it hits reality. You plan the elegant version, then the test stand, the pad, the certification process, and the calendar start negotiating. The important thing is that Blue Origin is no longer just a future promise. Blue Moon hardware is being tested. New Glenn is flying. NASA is working the interfaces. The backup path is becoming a real path. That matters because the next space age cannot be a single company story. If one vehicle, one pad, one engine family, one lander, or one billionaire's calendar can break the whole thing, then it is not infrastructure yet. It is a stunt with a dependency graph.
Chapter 5: A Visitor from Outside.
While humans are building routes outward, the universe occasionally sends something inward. That is the role of 3I Atlas in this episode. 3I Atlas is only the third known interstellar object detected passing through our solar system, after Oumuamua and 2I Borisov. NASA says it was discovered by the Atlas Survey Telescope in Chile and reported to the Minor Planet Center on July 1, 2025. Its high speed and hyperbolic trajectory showed it was not bound to the Sun. It was just passing through. No threat to Earth, no alien spacecraft, no secret invasion. Please return the emergency podcast microphone to its charging dock. The real story is better. Because 3I Atlas was active as a comet, and because multiple observatories could study it during its passage, scientists got a rare chance to sample chemistry from another stellar neighborhood without leaving home. In June 2026, NASA and ESA highlighted Webb observations that detected methane on 3I Atlas. ESA described it as the first direct methane detection on an interstellar visitor. Webb also confirmed that the comet was unusually rich in carbon dioxide relative to water, compared with typical solar system comets. That does not tell us the exact star system it came from, but it does tell us the object did not form under ordinary local conditions. Its chemistry is a message from a different freezer around a different young star in a different planetary construction site. This is the underrated half of the new space age. Yes, we're building rockets, landers, suits, stations, and lunar logistics, but we are also building a detection network. Survey telescopes find the visitor. Space telescopes read its spectrum. Mars and Jupiter missions may contribute observations from strange angles. Planetary defense systems double as discovery systems. Instruments built for one mission suddenly become useful when the solar system throws a rare object across the plate. That is a mature space civilization behavior. Not mature as in calm. We are absolutely not calm. Mature as in layered. We are starting to have enough machines in enough places that rare events become observable instead of just missed. The old space age was mostly about proving humans could leave Earth. The next one is about making Earth less scientifically isolated. That is bigger than rockets. Rockets are how you move mass. Instruments are how you move ignorance out of the way. So, has the next space age already started? If by space age we mean cities on Mars and hotels around Jupiter, no. Calm down. Drink water. But if we mean the beginning of a real, multi-layered space infrastructure, then yes, the signals are everywhere. A Martian meteorite is forcing scientists to revise what kinds of rock histories Mars might preserve. Artemis is moving from symbolic return to operational integration. SpaceX is trying to turn the largest rocket system ever built into a repeatable transportation machine. Blue Origin is turning lunar lander hardware and heavy lift into a second path. Messy, but necessary. And 3I Atlas shows that our instruments are getting good enough to catch chemistry from beyond the solar system before it disappears into the dark. That is not science fiction. It is also not guaranteed. The honest picture is more interesting than both extremes. The future is not nothing ever happens. It is not Mars colony by next Tuesday either. It is a grind of tests, failures, revisions, launches, sample papers, chamber runs, docking plans, and data releases. The next space age is not clean. It is cumulative. That is why the small stories matter. A mineral grain, a docking adapter, a tanker test, a vacuum chamber, a methane line in a spectrum. Those are not side notes. Those are the receipts.
OsirisPerseus is about exploring modern topics from breakthroughs to other foundations of science, tech, and engineering. Subscribe to join the expedition.